In this video, I'm going to talk about a linear regression. Linear regression, very important topic. So, what is a regression here? Regression means a relation. Now, let me draw the graph between x-axis and y-axis. X is an age, X is having a feature called age, and Y is having a feature called weight. Age is an input variable and weight is an output variable. Now between these two axes, like we have a data points here that got scattered across the axis between x and y. Now I wanted to draw a line here. Just, just wanted to make sure that it passes through 0. So this line is y is equal to mx plus c, right? Where m is a slope and c is an intercept. We have seen in our earlier video. Now we can also write this equation as y is equal to beta naught plus beta 1 into x. Some people also write this equation like this, but most of the people will be using an equation called h theta of x, which is called as hypothesis. H theta of x is equal to theta naught plus theta 1 into x. This is almost the same as this is same as y is equal to mx plus c, but we are here using a different notations, like theta naught is an intercept and theta 1 is a slope, right? So this equation we'll be using, right? Now what actually happens here, we are trying to do in a regression problem. What we'll be doing, we have a data set which is between x and y here. X is an age feature, X is having an age feature, and uh, y is having a weight feature, right? So we have a data set here. Now what we will be doing, we will be training this data set. We will be training data set. Okay, after training this data set, we would like to build a model. With this training data set, we would like to bring up some model here. So this is our model. So based on this model, actually we would like to have the hypothesis. We'll be having hypothesis. So this hypothesis will be giving the values of output by putting some values into the input. Here the input is age. By predicting by giving the values of age, we can predict the values of weight. So this is what the regression problem. But we have some different lines, right? Like, how do we come to know this is the best fit line? Actually, see, there is an actual point here and we are predicting some point here, and there is an actual point here and there is a predicted point here. So what we are trying to do is, we are trying to find the differences between the actual point and the predicted point. Everywhere we would like to bring up the differences between the actual point to the predicted point, and we would like to make that as a square. The minimum of these distances, whatever that line comes, it will be our best fit line. So the main aim for us to do is, like, we wanted to minimize this theta 1, theta naught and theta 1. We have to minimize this. So how we can minimize that? So this line can be drawn in different ways, right? Like, we don't suppose we don't know, we need to start at some point. We can also draw a line like this. We can also draw a line like this. There can be some infinite number of ways these lines can be passing through, right? But ultimate our aim is to find the best fit line, whatever whatever the minimal between these points to the predicted point, right? So to find that, we need to have something here called a cost function, which is a very important. Cost function is a very important, right? Now what I would like to write here, so our aim is to minimize theta naught and theta 1, right? So I wanted to write the cost function here, j of theta naught comma theta 1 is equal to 1 by, I wanted to just put this equation, just try to observe this, h theta of x minus y. I wanted to write here I as a subscript because these are the data points. I wanted to use I is equal to 1 to m will be the data points. So here I'll be making the square. So we all studied that in our mathematics, that the distance between the 2 points, right? Here we are finding the distances between uh, the hypothesis, which is a predicted point which is on the line, and actual value y, so that we wanted to find the minimum of this value. So whatever that is minimum, that will be the best fit line. So sum of all these values, sum of the differences of all these values to the average, I wanted to put here m, which divides by m, which will give an average value. I also wanted to use a constant here which is called 2, because to use I mean in further derivation we'll be using this equation for derivation purpose. So when we use derivatives, this 2 will become here, so it will become easy for us to calculate the values. So by putting 2 here, it doesn't make any difference actually for us to minimize the values of theta naught and theta 1. So it is okay even if we keep 2 here, which is a constant. Now, what we need to solve here? We need to solve here, as I told you, that we need to minimize this theta naught and theta 1. So let's say, we have this equation, right? H theta of x is equal to theta naught plus theta 1 into x. We have this equation, right? For an instance, let's say that theta naught is equal to 0. Now, for that we have an equation, we can draw the graph between x and y, which is passing through 0 because theta naught is equal to 0, which is having 0 intercept, right? So this line we can write it as theta of x is equal to theta 1 into x. So this will be our equation. Now what I would like to do here is I would like to draw the graph between the cost function here, because uh, we are putting theta naught is equal to 0, so our cost function will be j of theta 1, and I wanted to use the slope on the x-axis j of which is just simply theta 1, right? Now here what I would like to do here is I wanted to plot the values. Okay, let's say zero point 0.5 and 1, 1.5, 1.5, 2, 2.5. Let me also put some points here: 0.5, 1, 1.5, 2, 2.5. Now what I wanted to do here is I wanted to take the value of theta 1 here. Uh, Before that, I wanted to use the data set. Like suppose here we have x and y, right? I wanted to use, let me just write the data set. I wanted to use this data set 1 1 when x is equal to 1, y is equal to 1, x is equal to 2, y is equal to 2, x is equal to 3, and y is equal to 3. So I have this data set. That means let me write here 1, 2, and 3. 1, 2, and 3. So initially I wanted to put the data points here. Okay, I wanted to put the data points here. When x is equal to 1, y is equal to also 1. When x is equal to 2, y is equal to also 2. When x is equal to 3, y is equal to 3. Now this is my best fit line here. Okay, because the difference between the points and the predictions are 0. So I definitely know by looking at this graph, this is the minimal point, this is the best fit line. But for the best fit line, we would like to use the cost function here. So what is our cost function again? Let me just write our cost function. G of theta 1 is equal to 1 by 2m sigma I is equal to, we have 3 data points here. I wanted to use m is equal to 3, 2 into 3 it will be. So we have this equation, right? H theta of xi minus y of I whole square, right? So we have this equation right now. Now from here what I would like to do here is 1 by 6. I wanted to substitute the values of hypothesis. Here hypothesis, what is h theta of xi? H theta of xi is the predicted value, right? Predicted value is also 1 and the actual value is also 1. The green line shows the prediction, this is the green, right? And the red point shows the actual value. So both the points, both the prediction and actual value are on the same line. So here it will be 1 minus 1 whole square, and the second point will also go in the same way, 2 and 2. So 2 minus 2 whole square, and the third point is also the same way. So what I just got, j theta 1 is equal to 0. So when my theta 1 is equal to when my slope is equal to 1, when my slope is equal to 1, that means 1 by 1 is slope, my cost function will be at 0, that means in this line. So this point will be here. Now let me just put some other thing here, but I just wanted to use theta 1 is equal to theta 1 is equal to zero point 0.5. Suppose if I have a slope of 0 0.5, then if my slope is 0 0.5, what will be my line looks like? It will be somewhere like this, right? And this will be half, right? 0.5, and 0.5 by 1 will be my slope. So this will be my prediction. This will be my prediction point. This will be my prediction point here. This will be my prediction point here. So I wanted to use the same cost function here, 1 by 2 into 3. I is equal to 1 2 3, but I just wanted to put this in the equation. Here the slope is 0.5 here, 0.5 minus 1 whole square. And in the next point I will be having 1 actually, right? In the next, here it is 0.5, 0.5, in the next it will be having 1, here it will be. So 1 minus 2, 1 minus 2 plus, here again 1.5 it will be, 1.5 minus 3 whole square. So here you can see that this line is having the differences, right? Because it's not fitting on the best way actually. The line slope has dragged down a little bit, so it's tilted actually. So now here when you calculate this, you will have a value called, you may have a value called 0.58. So let me write here 0.58. So when x is equal to 0.5, you have a value called 0.58. It will be somewhere here. Okay, this is the point. Now similarly, when you wanted to calculate the value when theta naught is equal to theta 1 is equal to theta 1 is equal to 0, theta 1 is equal to 0, then you can just find again here. That means theta 1 is equal to 0 means you will have a line like this, because there won't be any slope, right? Theta 1 is equal to 0, the slope is 0. Then let me just write 1 2 into 3 here. I just wanted to use I wanted to directly use this formula actually here, which is 1 minus 1 whole square plus sorry, here 0 it is, right? 0 minus 1 whole square, 0 minus 2 whole square plus 0 minus 3 whole square, which will give a value called 2.3. So I have got a point here which is 2.3, right? Now likewise I will get for different values of theta 1, I will get another point here, I will get another point here, so I will get another point here, so that I can draw a graph like this, which is called